Hello and welcome. Today we're going to explore a powerful analytical technique called pyrolysis gas chromatography. It might sound complex, but it's a fascinating method scientists use to identify complex materials, from a single fiber to a tiny chip of paint. Let's break it down into its two main parts. First, we have the concept of pyrolysis. Imagine heating something to a very high temperature, but in an environment with no oxygen. Because there's no oxygen, the material doesn't burn. Instead, it thermally decomposes. This process breaks the large, tangled molecules of the sample into a collection of smaller, simpler, and more stable fragments. Think of it like taking a long, complicated necklace and breaking it into its individual beads and links to see what it's made of. The second part of the technique is gas chromatography, often just called GC. You can think of GC as a race for molecules. A mixture of gases is injected into a very long, thin tube, which is called a column. An inert gas, like helium, acts as a carrier, pushing the mixture through the tube. Different molecules travel through this column at different speeds based on their size and chemical properties. Some move quickly, while others lag behind. At the end of the column, a detector identifies each molecule as it finishes the race. This produces a unique graph, a chromatogram, which acts like a chemical fingerprint. So, how do we put these two together for pyrolysis gas chromatography, PYGC? This technique is essential when we need to analyze a sample that isn't a gas, like a solid piece of plastic or a dry drop of paint. You can't inject a solid directly into a GC. This is where the pyrolyzer comes in. A tiny piece of the sample is heated extremely rapidly to a very high temperature, often over 600 degrees Celsius. This flash of heat performs the pyrolysis, instantly turning the solid into a puff of gaseous fragments. This gas is then immediately swept into the gas chromatograph, which separates all the different fragments. The final result is a unique fingerprint called a pyrogram, which tells us the chemical composition of the original solid material. The applications for this are incredibly diverse. For example, in forensic science, it can be used to analyze paint chips from a car accident or fibers left at a crime scene. In environmental science, it's crucial for identifying and studying microplastics. In the world of art conservation, it can identify the binders and pigments in a centuries-old painting without damaging the artwork. It is also fundamental in the plastics industry for quality control and identifying materials for recycling. In summary, PYGC is a clever two-step process that allows us to analyze complex, non-volatile samples by first breaking them down and then separating the pieces to reveal their identity. Thank you so much for watching. If you found this video helpful, please give it a thumbs up, subscribe for more science content, and hit the notification bell so you don't miss our next video. Your support helps us create more content like this.